friends, and in this video we are going to find the solutions of the exercise 7.5 in CERT CBSE standard 12, and this video series is aimed for the students who are going to appear in the board examination year 2021 or maybe in the year 2022, and we are trying to solve each and every questions of the NCERT textbook. We started with the integration. Slowly we'll cover every possible exercise. Now we are into the exercise number 7.5, and this chapter deals with the partial fraction. Now what are partial fractions? Partial fractions are just like the normal fractions. You might have studied in the arithmetic that there are two types of fractions, proper fractions and the improper fractions. So proper fractions are the fractions like 1 over 7, 3 over 11, where the numerator is less than denominator. So these are called as proper fractions. Improper fractions are improper fractions. Improper fractions are just opposite of that, like 7 upon 3, 11 upon 5, where the numerator is greater than denominator. And these fractions can be expressed as the mixed fractions, like the 7 over 3 can be written as 3 to 1 over 7, or 11 by 5 can be written as 2 1 by 5, and this 2 1 by 7 can be written as 2 plus 1 by 7, and this is 2 plus 1 over 5. Same way the partial fractions are like a functions, are rational expressions where the numerator and denominator both are polynomials, like the fx over gx. And if the degree of polynomial, if degree of fx is less than degree of gx, they are called the proper rational fractions. Proper, but just you have to introduce a word called rational. And now the final secret information, that a proper fractions can be represented as sum or difference of two more proper fractions, like 3 by 11 can be written as 2 by 11 plus 1 by 11. So a proper fraction can be represented in the terms of two proper fractions. Same way a proper rational expression can be expressed as sum or difference of two or more proper rational fractions. Now since we have to integrate, now we'll go by the standard forms what are available in our portion so far, and we will learn to find the tricks how to resolve them into the proper fractions, and then how to find their integrals. So just I clear this screen. So one proper form is ax plus b over ax square plus bx plus c. Now this is a polynomial, linear polynomial of degree 1, and this is polynomial of degree 2. So this is proper rational fraction. Now here we see that what can we do with this. This is ax square plus bx plus c. This can be written as either the product of two linear fractions, like x minus alpha, a times x minus alpha x minus beta, or a times x minus alpha whole square plus minus beta. With this denominator can be written either as the product of two linear fractions. For example, if I write, we have the form ax plus b over x minus alpha and x minus beta. When you have this particular form, what you need to write, that you need to write this as a over x minus alpha plus b over x minus beta. Then you find the LCM, x minus alpha, x minus beta. This becomes ax minus beta plus bx minus alpha. and then by comparing these two coefficients, the numerators, because their denominators are all same, so by equating these two we have to find the value of a and value of b. Once you find the value of a and b, then your expression this can be written directly in terms of these two, and instead of integrating this expression you just integrate these two and the job is done. So one such form goes like this. Another form goes like this. When you have the form px plus q over x minus a whole square, then what you need to write? You need to write this as a x minus a plus b x minus a whole square, and then you continue doing the same thing. So let me clear these forms and then I write these four kind of forms directly. So this is ax plus b over x minus a x minus b. This you can write it as ax minus a plus b x minus b. Next is when you have ax plus b over x minus a whole square, then you write it as a over x minus a plus b over x minus a whole square. Then if you have the form ax square plus bx plus c, means a quadratic polynomial, and there you have cubic polynomial which are already factorized as the three linear polynomials like x minus a, x minus b, x minus c. Then you write instead a over x minus a plus b over x minus b plus c over x minus c. Now when you have a term like ax square plus bx plus c over x minus a and cx square plus dx plus e, means one linear and other quadratic, then you can resolve this as, for linear you write a over x minus a, and for quadratic you write bx plus c, means a standard linear form, over cx square plus dx plus e. And then again by taking the LCM and comparing the numerators of those combined fractions with the numerator of this fraction, because their denominators are same, you find the coefficients of a, b and c, and then you can just directly integrate these two rather than integrating this particular form. Now the one more is there. So these five forms are there which can help us to understand this question. Now these are just the simple narratives, explanations, and now we are going to implement the ideas by solving those questions from exercise 7.5, and the given questions may be or will be matching with one of these standard forms. So now let me clear this part of screen and then I go back to the exercise. Now we have question number 1, find the integral of x over x plus 1 and x plus 2. So what you have to do, that you write x over x plus 1 x plus 2 as a over x plus 1 plus b over x plus 2. So this becomes a x plus 2 plus b x plus 1 over x plus 1 x plus 2, and now you complete this part, that is x over x plus 1 x plus 2. Therefore just comparing the numerator, x is a over x plus 2 plus b over x plus 1. Now let x equal to minus 1. Why should I assume x equal to minus 1? Because this is x plus 1 and I want the b part to vanish, and x equal to minus 1 and x equal to minus 2. So slowly one by one, if I assume x is minus 1, this part becomes 0. If I assume x as -2, this part will vanish. So first I let x is -1, then what I get, -1 is -1 plus 1a, so a we have got directly as -1. When you write x is -2, then this part becomes -2, and this part becomes -2 plus 1, that is -b. So you are getting b as 2, a as -1. So this fraction becomes 2 over this minus 1 over this. Now instead of integrating this, we will be integrating these two, that is 2 over x plus 1 dx minus 1 over x plus 2 dx. Take 2 outside, 1 over x plus 1, that is log mod x plus 1 minus log mod x plus 2, and this is your answer. If you want to simplify this, you can write this as log x plus 1 whole square minus log x plus 2 plus c, and then log m minus log n is log m over n. So this becomes log x plus 1 whole square, I write this in mod, upon x plus 2 plus c. Many people leave the answer in this form also, they are same. So now this is done. Let me go for the next number. So now question number 2, find the integral of 1 over x square minus 9. So I write 1 over x square minus 9 as 1 over x minus 3 x plus 3, that is a over x minus 3 plus b over x plus 3, that is a times x plus 3 plus b times x minus 5 over x square minus 9. Like this, multiply these two, 1 over x square minus 9. So 1 is a times, sorry I have written minus 5, looks like this is minus 3. So a x plus 3 plus b x minus 3. Let x equal to 3. Let x equal to 3. So 3 minus 3 is 0. So this 3 plus 3 is 6. So 1 is 6a. Therefore a is 1 over 6. When x is minus 3, this part vanishes. This becomes minus 6b. Minus 6b is 1. So b is minus 1 over 6. So now I will integrate this part here, this part, and that is a is 1 over 6. So 1 over 6 integration 1 over x minus 3 dx minus 1 over 6 integration 1 over x plus 3 dx. This is 1 over 6 log mod, let me write 6 properly, log mod x minus 3 minus 1 by 6 log mod x plus 3 plus c. Take 1 by 6 common, and log m minus log n is log m over n. So log mod x minus 3 over x plus 3 plus c. This is way it will be solved. It's done. So question number 3 is I over integrations 3x minus 1 upon x minus 1, x minus 2, x minus 3, means there this is a linear polynomial and this is a cubical polynomial. So just I start, so I write 1 over a over x minus 1 plus b over x minus 2 plus c over x minus 3, and here you can write this as, because in our country the teachers have the unique problem of seeing the same pattern. So if you write any step missing, they will cut your marks. So there I write the LCM. I first take the LCM of these three co-prime numbers is x minus 1, x minus 2, x minus 3. This is a times x minus 2, x minus 3 plus b times x minus 1, x minus 3 plus c times x minus 1x minus 2. So this part everything is properly seen. So now this is 1 over this, same thing. So I just remove one thing because I want to compare only the numerator. So I write this 1 as this. So slowly first I'll take x equal to 1. So when you take x is 1, so this becomes 1 equal to this gone, 1 minus 1 minus 1 minus 2, that is 2a. So you are getting a as half. When you write x equal to 2, then this is gone. Wherever x minus 2 is, there is gone. X minus 2 gone. X minus 2 is also gone. Now you're left with b times. So 1 equal to b times x minus 1. That is 2 minus 1, 1. And this is minus. So this is minus b. And then you take x is 3. Then this is gone. This is gone. 3 minus 1 is 2. And the 3 minus 2 is 1. So it is 1 is c. So c you're getting as 1. So now we have half. This is half x minus 1. This is minus 1 x minus 2. And this is 1 over this. So instead of integrating this, we will directly write half integration of 1 over x minus 1 dx minus integration of 1 over x minus 2 dx. Let me remove this part, these are not required anymore. And the purpose of solving them is also solved. So last one is plus 1 over x minus 3 dx. So that is half log mod x minus 1 minus log mod x minus 2 plus log mod x minus 3 plus c. So these are the ways these questions can be solved. In the next video, we will solve the remaining questions of this exercise 7.5. Thank you very much. Just subscribe to our channel and keep practicing with us.